going to do is I'm going to multiply these.
This conference will now be recorded.
So I'm going to multiply this by these two power values. Okay. Are you there with me?
Yes, yes, I'm here.
Yeah. Okay. So I'll say 0 because
Okay.
0 into 1 is 0.
Okay.
Or maybe since I know the values, let me start from the left corner itself. So
Okay.
the value for 2 power 7 is 128 and 128 into 1. So I'll write 128. Okay.
Okay.
Plus, and the second 0 into 64.
Okay.
This will be 0.
Okay.
And I'll say 32 into
Into 1.
1. Yeah. So I'll say 32.
Okay.
And then I'll say 0 into 16.
0.
Which is 0. Right. And I'll say 8 into
8.
0. Sorry, 8 into 1. Yeah.
8 to 1, 8.
Yeah, correct. And then 0 into 4 is 0.
0.
And 1 into
2.
2. And then 0 into 1, which is
0.
right. So this will give me some value. And that will become my first octet value in decimal format. So 128 plus 32 plus 8 plus 2. So 128 plus 32 is 1, how much? 160.
6, yes.
Then this will be 168.
8. 70, 170.
170. So this is how I'll get the value. Okay.
Okay.
This was my example, and here in the slide you'll have one other example. Just first two values are 1 and others are 0, so you'll get a different result. Okay, and then this.
Okay.
You understand the concept how we convert?
Yes. Yes. So the 1, 2, 4, 6. Sorry, 1, 2, 4, 8. Those numbers are permanent. Those remain as they are. You
Yes,
have, like,
these things. Yes.
Okay. So every time you just have to remember that and then keep on multiplying with the number that you get.
Correct.
Okay.
And
Gotcha.
finally you sum it up. Yeah, sum it up, and you'll get the decimal value.
Okay. And then what
Okay.
was the? Can you like go one slide before this one that you showed?
Yeah. This one.
Yeah. Okay. So the first number is the number that we just got, right?
Yeah. In this
170
case.
we got.
Yeah, I mean, I showed you binary to decimal conversion. Now I will tell you decimal to binary conversion. At that time, I will discuss this.
Oh, okay.
This was about converting
Yeah, so
binary
that's
to
what I was
decimal.
asking. The 170 is the number that's here, 192, right? That's what I'm trying to compare it.
Yes.
Okay.
Yes,
Gotcha.
correct.
Okay.
Correct. And second octet they got 168.
Right.
Third octet they got 10, and fourth octet using the same thing. You
Right.
multiply by these two power values and then sum it up. You'll get the value.
Okay. So then if we need to get from here to this number, then we just have to divide by 2. So we get that number, or no?
Not exactly divide. If you want to get those
No,
numbers,
then
again
you'll only get one number. Yeah. No. It won't work.
it won't work. Yeah. So again, you have to go back to this same chart. This chart is very useful in converting both binary to decimal, decimal to binary. So let's say you have got, I've got, let's say some random number. Let me take from that only. Let's say 168. Okay.
Mm-hmm.
Okay. Now you want to convert that into binary.
Okay.
Okay. Now what you're going to see is, you have to first choose from these values. You have to choose the value which is, I can say, less than this, but not not very less. I mean the greatest of the value from this number has to be picked up first. So the greatest value in the octet is 128.
Right.
But it should be less than 168 because our number is 168. Right. So our number is 168. You have to pick up a value which is less than that, but greatest
More
of all the numbers.
Right. All the numbers. Yeah.
All these numbers. So I'll say 128. Then now we have 128. Now how much is remaining? 168 minus 128, how much does it give? It gives 40.
60.
We have got
40 left.
40 remaining. Yeah. Now you have to choose the number.
That sums up to 40.
Yeah, that sums up to 40, which is like greater than or equal to 40, but it
Right.
is greatest of the remaining.
Right, got it.
Right. So
Right.
64 is not that number, so I'll say 0.
Right. Mhm.
32 seems to be the number that which should be good for us
Right.
because it is less than 40 and greatest of them
Right.
over there, which meets our criteria. 32. Now we have added 32. How much is remaining now?
8.
The 8 is remaining. Yeah. I will see which one matches our value.
8 will match. So 0 and then 8 and then 0, 0, 0.
Yeah. So 0 and then plus 8. 0.
Right. Got it.
1, 2, 3, 4, 5, 6, 7, 8. Right. So we got our binary value 1, 0, 1, 0, 1, 0, 0, 0. So this is the binary value. Let's see if we have got it. So this is the value which we got for 168.
Right.
1, 0, 1, 0, 1, 0, 0.
Right.
Okay.
Right.
Little tricky, it needs a lot of practice actually to convert.
Okay.
So I'll give you at the end of the class, I'll give you some examples and homework to practice. Okay.
Okay.
So this chart is going to be used, very useful for all the
Right.
conversions. Okay.
Okay.
So now that we know IP address, so each computer, each device has to be assigned an IP address. So on our local computer, there's a lot of background noise. Is it from your side or Dikshay?
No, my side is nothing.
Dikshay, can you mute yourself? Okay, thank you. Assigning an IP address to your local computers. Have you ever checked the IP address of your computer?
I have checked it, yes.
Okay. 1 second, somebody has come.
Okay.
Hello, sorry for that. Okay. So on a Windows computer, assigning IP address is simple. You would need to go to the control panel. Okay.
Mm-hmm.
And then go to network and internet. Okay.
Right.
Network and sharing center, manage the network connections. Then you can set for the adapter, local area network, and then under that you'll go to properties.
Okay.
It will take you to this page. Then here you will
Mm-hmm.
have IPv4 settings.
Okay.
Click on properties of that. It will open this window. In this window, you'll have IP address, subnet mask, default gateway. I will discuss all of this. Don't worry. So right now we're discussing only about IP address. So what is the
Yes.
subnet mask? What is the default gateway? We'll cover all those things.
Okay.
There is a command to check IP address on Windows. You can just open the command prompt. This will be a command prompt like this. And then you can use this command. 1 second. Let me call this to mute himself. It's a lot of background noise.
Okay. Sorry. What do we have to type in there? Okay, I did that. Hello?
Yeah. Can you hear me now?
Okay. Yes, I can. Sorry.
Yeah. Yeah. So you will get a output of this ipconfig command on a Windows computer, similar to like this. The first adapter that you have got in the output will give you an IP address. I am on a
Okay.
wireless LAN adapter, and it is giving
Right.
me IPv4 address that I have 192.168.0.3. So this is my IP address. If somebody
Okay.
asks me, tell me your PC or computer's IP address, so I'll go to command prompt, I'll type this command, and I will pick up this IP address
Oh,
192.168.3. I'll give that to the requester. Okay.
okay.
And to check, this was through command line, just to check like this, the regular way. So you'll go to network, control panel, network and internet, and center, and then you will say change adapter. Then you'll go to your network connection. So mine is this wireless, and I'll go to
Yeah.
properties. Okay. So I clicked on status and I clicked on details. This is another way to get the IP address. Okay, let me show
Okay.
you again. Okay, right click the adapter, click on status. Okay,
Okay. Okay.
it will get you this page.
Okay.
This window. In this window, you click on details.
Right.
Okay, so here it's gonna give you the IP address 192.168.0.3. So this is what I have
Okay.
got. Okay, this is my IP
Mhm.
address. Okay, okay,
Gotcha.
okay. So now that we know about IP address, and we know that it is a 32-bit long IP address, so we can find out how many IP addresses are possible. Since we know the bits, 32 bits, and we know how to convert that into decimal, how
Mm-hmm.
many IP addresses are possible? So the total possibilities would be all octets would be 0, or all
Right.
octets would be 1. So if all the octets are 1, 1, 1, 1, 1, so converting them to decimal give you a value of 255.
Okay.
So it's like, like this: 128 plus 64 plus 32 plus 15 plus 8 plus 4 plus 2 plus 1. Total
Uh-huh.
all values are, let's say, 1. So first, all are 1, you multiply and then add. Okay, so the value that you
Mm-hmm.
get is 255. This is my first octet. Similarly, let's say second octet, also all ones. Third octet, also all ones. Fourth octet, also
Mm-hmm.
all. This is what I get. Starts from 0002 255.255.255. So
Okay.
total value, number of IP addresses, 255 into 255, like you will have millions of IP addresses.
Right.
Is that from you? I'm getting a lot of background noise.
I don't have anything bad. I don't know why you're hearing.
Okay, 1 second. Okay, it's gone now. Do you also hear the same noise? Or I am the only one hearing this?
You are the only one.
Okay. It's gone now. Okay, so 0.0.0 to 255, 255, 255, 250. This is the total IP addresses that we can get in a 32-bit IPv4 address. Okay. Now, these wide range of IP addresses, billions or millions of IP addresses, we have categorized or divided into different class, and we will discuss that. Okay. This
Okay.
is classification, IP address classification. So IP addresses are divided into 5 classes: class A, class B, class C. Now, how is the division? So
Okay.
division is based upon value of first octet.
Okay. Hello?
Yeah, I'm getting a lot of disturbance. I'm hearing some noises like somebody's talking. Some a lady, or maybe a student talking to guy. Now it is
I'll
gone.
just mute myself. That's okay. If I have a question, I'll unmute it. Okay?
Okay.
Thanks.
Yeah. Okay. So IP addresses are divided into 5 class. This class is based upon the value of first octet. Okay. So we have seen that there are 4 octets in IPv4. Okay. First octet, second octet, third octet, and fourth octet. The value of first octet, if it falls under 0 to 127, that will be called as a class A IP address. I repeat once again, the value of first octet, if it falls between 0 to 127, that will be called as a class A IP address. Okay. If the value of first octet falls under 128 to 191, that will be called as class B IP address. Okay. If the value of first octet falls under 192 to 223, that will be called as a class C IP address. Okay. Then class D, the value of first octet falls between 224 to 239, that will be a class D, and then it falls on 240 to 255, it will be a class E. On the internet, we are using for assignment and for use purpose only these 3 classes A, B, and C used in LAN and WAN. Class D is reserved for multicasting. So I'll discuss in details what is multicasting and where we are using it. So don't worry about that. For now, just remember that we are using only class A, class B, and class C IP addresses for assignment or for logical assignment to devices. Class E, this is used, or maybe you can say this is not used on the internet, but it is reserved for research and development and government DRDO purpose. This is not used by any organization or the users. This is totally reserved for a research purpose. So clear on this?
I'm clear.
Then there are types of communication. You have got unicast communication, broadcast communication, and multicast communication. So what is unicast communication? Unicast communication is when you know the destination, you know the address, and you are sending the message directly to the destination. Let's say in a classroom, a teacher wants to call out to one student or wants to say, okay, you give me the answer. So he or she will take the name of the student and then he will answer the question, right? So that will be like, you know the name, you know the person, and you are talking directly to that person. That is a unicast, one-to-one. In broadcast, it's like teacher teaching to all the students, you know, not just one specific student asking any one specific student. It's one to all. It's a broadcast communication. Then you have got a multicast. In multicast, it's one person talking to selected people only, a group. So let's say a class is divided into multiple groups. So first the teacher goes and talk to the first group, assigns them some work, then to the second group, like that. It's a multicast only to the selected group. Okay.
Right.
That was in normal terms, day-to-day life, and the digital terms, it is like the source knows the destination, and when it sends with the destination address. So that becomes a unicast one-to-one communication.
Okay.
So the process of sending a data packet from one host to another individual host. Okay, that is unicast. In the broadcast transmission, it is a process of sending a packet from one host to all the hosts in the network. Okay. And in multicast, the process of sending a packet from one host to a selected group of hosts, and it could be in different networks also. And as we discussed, class D is reserved for multicasting. So now you know what is multicast. Multicast is nothing but sending messaging a selected group of people. So that is multicast. For that, the group has to have some ID, right?
Right.
So for that group to have some ID, some address, that address is taken from class D.
Okay.
Okay, so we have seen that we have reserved class D for multicasting, right? The IP assignment for each devices will be from class ABC, but when you do multicasting, the group has to have some ID, right? So that ID or that address would be class D.
Okay.
Okay. Examples in real life, you have got live TV and radio broadcast on your desktop. You have got distance learning. Distance learning, like multiple students can jump in and then do the course. You have got multiple file transfer. You have got YouTube, for example. You have got video conferencing tools. Right now, we are doing a
Right.
GoToMeeting conference, right? So these are all examples of broadcast and multicast.
Okay.
Okay, so now we are entering into little bit complex thing. Okay,
Okay.
what is a network? What is a host? How do we identify a network? How do you identify a
Host.
particular host? Now, so far we have seen two types. One is classification of IP addresses based upon first octet, and they are called as class A, class B, class C. The
Right.
second we have seen type of communication, right? Unicast, multicast, and broadcast.
Broadcast.
Now, now we are going into network and host portion. So IP address is divided into network and host portion.
Okay.
IP address, a 32-bit address, 4 octets. Then these 4 octets, now they will be represented in the network and host portion values. Now, what is a network value? What is a host value? So host value is nothing but a specific device in the network. It will be called as a host. Network will be a set of devices,
Okay.
okay, in the same network. Okay, so by default, we have reserved, by default, there are portion reserved for each class. So let's start with class A. In class A, the first octet is reserved for network portion. So let's say the first octet is a network portion to identify the network, the set of devices in class A network. This is the network portion of class A,
Okay.
first octet. In class B, okay, this is wrong. It's class B, the first 2 octets would be reserved, or you can say the first 2 octets by default are the network portion. And in
Network.
class C, the first 3 octets are the network portion. So what does it mean? It means that the values would change only in the host portion for a specific network.
Okay.
We'll see. Example, for class C, the first 3 portions are network portion and only the last octet is the host portion. So for a IP address or for a devices set of devices to be in the same network, the host portion should be host portion can vary, but the network portion has to be same,
Same.
so that we can say they are in the same network. Let's say
Okay.
my device is having IP address 192.168.1.1. Well, I know that the 3 octets are network portion. So for me to say that another device is also in my network, the network portion of the other device also should match my network portion. So my network portion is this 192.168.1,
Right.
right? 3 octets for class C. Now, how do I know this is a class C? So I know because the first octet value is falling under the this one
190.
192 to 224. So the class A was 0 to 128 and B,
128 to 191.
yeah, so 120, 191, right? So since it is starting with 192, I know it is a class C IP address. And in class C, I know that first 3 octets are network portion.
Right.
Okay, so I know my network portion here. Okay. Now for me to say the other device is also in my network, it has to have the same network portion, like 192.168.1. The host portion can change. So because it has to have its own address. So let's say it has got two. So I will say, okay, mine is dot one and the other device IP address is dot two. We are in the same network.
Right.
Okay. So how many such devices can we have? We can have 0 to 255,
Okay.
0 to 255, which we can say are in the same network
Same network.
for a class C. Yeah. Okay. So in a network, there are few IP addresses which are used for identification and broadcast. This cannot be assigned to the devices. What are those
Right.
IP addresses? These are like network address, or you can say network ID. So the first IP address of the network is reserved for ID or identification, and it's called as network ID or a network address.
Network.
It will
Okay.
never be assigned to a device. Okay.
Okay.
Then the last IP address of the network is reserved for broadcast.
Okay.
So this also would not be assigned to any device.
Device. Okay.
Okay. So if I want to send a broadcast to all the devices in my network from dot one to all like dot three, dot four, what I will say source is my IP address and I will put the destination as dot 255.
255. Okay.
And I put the destination as dot 255
It's
with
all
the
the
help of the
points
protocol.
for
Yeah. So it will be sent to everybody on the
everybody
network.
between that range. Yeah.
Correct. So the valid IP addresses will be always network addresses, the total network addresses, the total IP address in the network minus the two IPs. Okay. In class B, the first 2 octets are network portion and the second 2 octets are the host portion. Okay.
Okay.
So in this example, let's say 172.16.00. This will be the first value which will be reserved and called as network ID, and then the last would be 172.16.255 that will be the broadcast address. And in between, you have got lots of values, right? 0.1, and you've got 0.1 to 0.255, then you'll have 1.0 to 1.255, then you'll have 2.0 to 2.255, like that goes on 255.0 to 255.255.
Right.
So it has got more hosts. Class C has got only 255 IP address available.
Right.
So maximum IPs in class C network would be 255,
Right.
right? And in class B, since it has got more octets or more portion on
Host.
the host side, it will be having more IP addresses. So it will be 255 into 255. That many IP addresses are available in a class B network. Okay. Class A,
Gotcha.
only the first octet is the network portion, remaining the 3 octets are the host portion. So it has got the maximum number of IP addresses in a single network. Okay. Let's say example 10.0.0.0. So this is the first IP of the 10.0 network and it will be a network ID. The last would be 10.255.255.255 broadcast address. and between them is the valid IP addresses for 10 dot network, which is huge. It's like 255 into 255 into 255.
25.
Huge number, yeah. So here I've got some calculations. Number of hosts in each class. In class C, host bits are available only 8 bits, right? The last octet. So
Right.
the number of IP addresses that we have got is 2 power 8, which is 256. Okay. And from those 256, we have to minus 2 because one is reserved for network ID and the last one is reserved for broadcast address. So the actual valid IP available for class C network is 254. Okay.
54.
Class B, you've got host bit 16. Total IP address that can be available is 2 power 16, which is 65536, a huge number. 65,536 IP addresses we can get in a class B network. Okay, and then minus 2 for valid IPs. In class A, you have got 24 host bits. 2 power 24. I think how much
Right.
it is? It's like crores, right? 16 something. Then minus 2.
Mm.
First and last address in each range are reserved for network ID and broadcast ID,
Forecast
as
ID.
we discussed. Okay, I think we have already discussed this one. Network ID is to identify the network, first IP of the range. Network ID means all zeros in the host portion. Okay, so let me clarify this. What does it mean? So it means that when you want to write a network ID in the decimal format or the binary format, what you will say is to represent the network ID, you will see host portion zeros. So what it means is this is the host portion, the last octet,
Right.
and it's saying all zeros. This is my network ID.
Okay.
Simple. Broadcast ID, all ones in the host portion. So I'll put all ones in the host portion. It will be. I put
One.
all ones in the host portion. Let me show what I mean. This is the binary of this number. Okay,
Okay.
and in this case, it is saying it has to be all zeros.
Right.
And in this broadcast ID, it is saying it has to be all ones. So if we see all ones and we convert that to decimal, it comes out to be 255.
255.
Valid IPs lie between the network address and the broadcast address. Only valid IP can be assigned to the host or the clients. Okay. Now let's come to the second part of the IP address, which is subnet mask. So basically, it differentiates the network portion and the host portion.
Okay.
Okay. How does it differentiate? So what it does is on a given IP address, you will represent the network by all ones. Network portion will be represented by all
All
ones.
one.
Okay, and the host portion will be represented by all zeros. So
Okay.
when you write that in the decimal format, that is called as a mask or subnet mask.
Okay.
Very simple plain guideline. All network portion represented by 1, convert that to decimal. All host portion bits, all zeros. Okay,
Mm-hmm.
that will give you a subnet mask. So let's see in our
Right.
case,
Yeah.
in our example. Okay,
Okay.
so what it says is it has got some decimal value 192, right? So
Right.
I will not convert that. What it says is portion, network portion, it has to be represented by all ones.
Right.
So if in an octet all 8 bits are 1, the value I get in decimal is 255. I know it,
Uh-huh.
right?
Right.
And second is also a network portion. So same value I will get.
Uh-huh.
And third portion, third octet is also a network portion
Uh-huh.
for class
That's
C. So I'll get
network.
the same value,
Right.
right?
Right.
And the fourth octet is a host portion.
What?
And for
That's a
subnet
zero.
mask, it has to be a 0,
Zero. Okay.
right? So this will become my subnet mask.
So the submask remains the same, like 255.255.255.
Yeah, so it will remain the same as long as a device in the same network. So it
Network.
will
Okay.
be the same subnet mask for all the devices from 1.1 to 1.255.
Okay.
Okay? And the mask would remain same for class C. Basically, this is a mask for the class C mask.
Okay.
Okay. So in class C, we know that first three octets are network portion, and
Okay.
all network portions binary is all 111. So
Right.
it will 255, 255. First three octets will be 255, 255, 255. So for class C, I can just say that for class C, the default subnet mask is 255.255.255.0. Okay.
Right.
Okay. So whenever I see a class C IP address, I know the subnet mask.
Right. That's what I was asking. Yes.
Yeah, correct. So instead of let's say this 192, I've got some IP address which says 197. Okay,
Uh-huh.
197.10.40.1. Even for this also, I'll have the same subnet mask.
Right.
Okay? So this is the default subnet mask for class C.
Class C. So whenever you identify it's a class C, the subnet mask should will be this only,
Yes,
255.250. Okay, that's
yes,
good.
yes. The default subnet mask would be this. This is one way of representing. This is another way of representing. That other way is called as CIDR notation,
Okay.
okay, which is like slash and then you tell the bits. How
Okay.
many bits in your network? Okay, portion. So in class C, I've got how many network portion? 3 octets. 3 octets means 8 into 3, which is 24. So I will say slash 24.
Okay.
Okay, this is CIDR notation.
Okay.
Classless inter-domain routing notation.
Okay.
Okay. This slash notation, this basically it is telling you how many bits are there for network portion.
Network portion.
Okay, so these class C 3 octets are there for network portion.
Yes.
3 into 8.
8.
Okay,
Yes.
yeah, 24 like that. Okay.
Yes.
Either you can represent the mask like this, or you can just say slash 24.
Right.
Okay, easy to understand. Similarly for class B, the first 2 octets are the network portion, so 255, 255, and then 00 for host portion. For class C, first 3 octets are for the network portion, so 255, 255, and then the last is the host portion, which will be a 0. So this is the default subnet mask for class C. This is the default subnet mask for class B, and this is the default subnet mask for class A.
Right.
Right? Okay. There are some IPs which are reserved. We have seen two of them, class D and class C. We know it is reserved, and we have also seen network ID and broadcast ID. And now the fourth point, address starting with 0 is not valid. Okay,
Right.
okay, so not used. And then third one, sorry, the last one, 127 dot access. This is reserved for loopback testing, testing the TCP IP stack.
Okay.
So your device, every device would have a adapter, a network adapter, which understands the logic like IP addressing. Okay,
Okay.
so to test your network adapter, okay,
Uh-huh.
we use this for testing.
Okay.
I'll show you here. Okay,
Okay.
So I can test my network adapter whether it is working properly or not. Okay, by
Okay.
using 127 address. Okay, I'll say ping. So ping is a command to send some ICMP packets
Okay.
messages to the adapter. Okay, to send it, and I'll say 127 dot, and you can choose any. So I'll choose
Okay.
0.0.1. Anything starting with 127,
One
it will
twenty
go to
seven.
the network adapter,
Okay.
and you can say that it is replying. So you will get a value, by
Okay.
32 by sent and the TTL 128, and the transfer sent 4 and lost 0, and you got a reply, so successful. So network adapter is working properly. So this
Okay.
is reserved for loopback addresses of the network adapter itself. Okay.
Okay.
Okay. So we have checked the ping command. You can use the ping command to test connectivity between two devices.
Okay.
Default gateway. Okay, so we have seen IP, we have seen subnet mask. Now let's discuss about the default gateway. So what is default gateway? Any guesses with the name?
It's a different name, maybe. I don't know. Different IP.
Okay. No. So we have seen networks. We have seen devices. Devices within the same network, okay, are able to communicate with each other with the help of a centralized device, which is a switch, right? But if they want to go and communicate to another network,
Okay.
okay, if they want to communicate with another network, there should be somebody who should tell them, okay, so if you want to go to that address, this is how you
Okay.
should go, right?
Oh, got it.
Right, kind of a so I am on a 192.168.1 network. My address is, say, let's say 1.10, and I have a friend in another location or another network.
Uh-huh.
IP is, let's say, 2.5. Now,
Okay.
as long as I am in the same network of mine, which is this, I have no problem. I don't need any gateway or anything. Okay,
Okay.
and my switch is able to understand where are the different devices placed in the network. But
Okay.
if I want to communicate with another network, switch would
Okay.
not know. Okay, so there has to be a new device,
Okay.
right? So that is a gateway. So when I am sending a packet to, let's say this is, I'm saying myself as A, and let's say I'm sending my friend as B, and I want to
Yeah.
communicate with B. Okay, so it will go, it does not know how to reach B, right?
Right.
Because
Right.
B is not in the same network. So it
Right.
is going to send that packet to gateway. Now
Right.
this gateway has got something called as table. I'll discuss more in detail about
Okay.
it. Don't worry. When we discuss routing, no, at that time I will
Okay.
tell you about this also, routing table. So this gateway has got something called as routing table, and it knows about where are the different networks located. It has got
Okay.
different legs. Okay, so one
Okay.
leg, it will be having network of mine like network A, and another leg it will be having B. So it takes the data would be incoming packet will be coming to this, hitting on leg A of the gateway. Okay, and it sees that A want to send to B. It will
Right.
send it to the other network. So this is the gateway. So you need to have the gateway IP address.
Okay.
So basically, default gateway is used to have communication possible between two different networks.
Okay.
Any guesses what kind of a device it could be?
Like the router?
Yes.
Okay.
Okay. Okay. Now you have got ipconfig. We have seen ipconfig command. You have one more command which is like ipconfig slash all. So this
Okay.
gives you more details. Apart from your IP subnet and gateway, it gives you DNS servers also.
Okay.
So you can DNS, DHCP. Yeah, here you can see here.
Okay.
So apart from the IP address, which is this 192.168.0.3, this is my IP address. This is the subnet mask. Okay,
Okay.
I've got default gateway 0.1. I've got DHCP servers, same, and
Right.
then I've got DNS servers. So more details. In the previous just IP config, we just got few details, but if you
Right.
say slash all, you'll get more details. DHCP and
Okay.
DNS IP addresses also. Okay.
Mhm.
Loopback address used for testing. We have seen that you ping the IP address anything in the 127 dot range, and that will be for loopback testing. Now, private and public IP address. What is a private IP and what is a public IP? Okay. 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 Let's continue this tomorrow. Actually, we have already crossed time. Um,
Okay.
you have any questions so far? What we have discussed?
No, I'm fine. I'll have to go
Fine, right?
through every all my notes and then I'll have questions maybe tomorrow.
Yeah, sure. So today we have seen binary, decimal,
Yep.
and IPv4 addressing. Okay,
Right.
and we have seen classes.
Hmm.
We have seen types of communication.
Right.
Okay,
Okay.
and what we have seen is subnet mask.
Yes.
Okay,
Okay.
and then some commands, some basic commands.
Yes.
Okay, these are topics that we discussed today. Tomorrow we will discuss about private and public IP. Okay.
Okay. Alrighty.
Okay. See you tomorrow then.
Yep. Thank you.
Yeah. Welcome. Bye.
Bye bye.